The most commonly used techniques for investigating the relationship between two quantitative variables are correlation and regression. Correlation quantifies the strength of the linear relationship between a pair of variables, whereas regression expresses the relationship in the form of an equation. Coming to the definition of correlation, correlation is a statistical tool that helps to measure and analyze the degree of relationship between two variables. It's not about only two variables, it can be used to study two or more than two variables, means to correlate or correlation between two or more than two variables. And this is the exact meaning of correlation. Coming to the coefficient of correlation, the measure of correlation is called as the correlation coefficient. The degree of relationship is expressed by coefficient which range from -1 to +1. So when we are going to measure the correlation, then we call it as a correlation coefficient. And the degree of correlations exist between -1 to +1. The correlation analysis enable us to have an idea about the degree and the direction of relationship between two variables under the study. It shows us the degree and direction between two variables. As we are going to study the types of correlation, there are two types of correlation, positive correlation and negative correlation. Positive correlation means when variable both are in a positive direction, that means both in a same direction, is called positive correlation. If one variable is positive and one is negative, which means inverse relation between two variables is called as a negative correlation. And hence the correlation is said to be positive correlation if the value of two variables changing with the same direction. For example, public expenditure and sales. As the expenditure increases, the sales also get increases. And the height and weight, as they both are same in direction. And the negative correlation. The correlation is said to be negative correlation when the values of variables change with opposite direction. For example, price and quantity demand. As the price increases, the quantity of the demanded will be decreases. Now coming to the Karl Pearson's coefficient of correlation, R is the most common correlation coefficient which measures the degree of linear relationship between two variables x and y. And the direction of change is indicated by the sign positive and negative. And do remember, whenever we are going to measure the correlations, we call it as a coefficient of correlation and it is denoted by R and is in the range of -1 to +1. And here to determine the direction, whether in the same direction or a negative direction, we use the positive and negative sign to indicate. After this, we have a interpretation of coefficient of correlation. In this, we have a direction from positive to negative. If R is equal to +1, then the two variables are said to be in the same direction. If R is equal to -1, the two variables are perfect and negative, and if R is equal to 0, then the two variables are not correlated between variables. It means that there exists no correlation between the variables if R is equal to 0. Until now, we have studied the correlations, and let's start the analysis of regression. Regression analysis is a very powerful tool in the field of statistical analysis in predicting the value of one variable given the value of another variable when those variables are related to each other. Regression analysis is a mathematical measure of average relationship between two or more variables. So in this we are not showing the relationship of two variables, either than we are getting to predict one variable with another variable. We are going to predict the value of variable when both the value are related to each other. Advantages of regression analysis are: regression analysis provides estimation of values of dependent variables from the values of independent variables. Regression analysis also helps to obtain a measure of error involved in using the regression line as a basis of estimation. Here, there exist dependent variables on independent variables. So, we are going to show the relationship between dependent and independent variables. Coming to the regression line is a line which gives the best estimate of one variable from value of another given variable. The regression line gives the average relationship between two variables in a mathematical form. As we seen in the correlation, we just have the relationship like a public expenditure and a sale, but in this, we can check the effect of one variable on another by using the regression lines. There always existed two regression lines x and y. Likewise, regression lines of x on y gives the best estimate for the value of x for any specific given values of y. X is equal to a plus by. Similarly, regression line of a y on x where a is the y-intercept, b is the slope of a line, dependent variable is y and independent variable is x. In the equation y is equal to a plus bx. Comparing correlation analysis versus regression analysis. Regression is the average relationship between two variables, while the correlation need not imply cause and effect relationship between the variables that indicate the cause and effect relationship between the variables. When the correlation coefficient is 0, the lines are perpendicular, and when it is plus or minus 1, the regression lines are parallel and coincide. Thank you.